Hi, I am Annesha Dash. Today I am going to explain about that convolutional neural network. So, what is it and what is the real type of scenario? So, we'll discuss today. So, let's start. First, let me share my screen. Okay, I think it's visible. So, when I was in college, that time in my college, one attendance system is there. What is this? When I went to college, there is one phone, and first they capture my face and then eyes, and based on that, it allows me to enter the college premises. So this is one kind of application of the CNN. And nowadays, you can see the traffic signal system is very advanced. They can easily recognize you wear helmet or not. If you not wear helmet, then it charged automatically cut from your account. Okay, so this is the helmet detection system, that man is not wearing helmet and that man is wearing helmet. Okay, so let's see what is CNN actually. This is the book's definition of that CNN. So please read it. I will not explain through book. I'll explain the real time of scenario. Suppose I have one child. The child age is 3. He or she don't know about that 9 digit. Okay, so I want to teach her how to write or how to draw the 9. So the first day I will teach her the small ages of that 9, and these type of ages first day I will teach her. Then her brain little bit advanced. Next day I will teach her some little complex curve. See, this I will teach his or her next day. These are these. Okay, and her brain is improving. Her brain wants to catch more information. Then at last day I will teach her more complex things compared to the previous days. Exact. The CNN works like this. In CNN, what happens? In CNN, there is image. What is image? We captured some image through our phone, through our digital Sony Nikon camera. So what is image? Image is the matrix. I think we all know matrix. We have learned matrix in our 10 or 12th class. We all know. And primarily, image are 2 types. One is black and white image. There is 2 channel. Okay, black and white. Another is RGB. There is 3 channel: red, green and blue. So see, this is the image and this is the filter. What is filter? Suppose I have applied one job and that job requirement is there. Please upload your passport photo and your background should be white. Why white? Because my my face is clear because of that white background. Filter do exact things, same things. Actually, filter extract the important feature from that image. I think it is clear. Filter extract the important information, not important information. Okay. Now imagine only information extract from that image and the multiplication, element wise multiplication is going on. Element wise multiplication is going on between that image and the filter, and my feature map has created. Let's play one game. Okay, here, sorry, because of my bad network it takes some time. Please stay with me. See here, this is the 0 image and I have played. I'm playing this. Okay, see, element wise multiplication and addition is going on, and at last stage the feature map has created. Okay, then see my PPT now. Here, consider my image size is 5 cross 5 and here I have used that 3 cross 3 filter. Here one formula is there. What is the formula? N minus A plus 1. What is N? N is the input size of the particular image. What is F? F is filter. I have already discussed about the filter. And 1. So my answer is 5 minus 3 plus 1, 3. So my information loses here. My input size is 5 cross 5 and my output size is 3 cross 3. So I have loosened my information, image information. So what I will do? There is also solution. What is the solution? I have to add extra layer bottom of that particular image and top of that particular image. I will add extra layer that bottom of the image and top of the image. Because of that, we will not lose any kind of information. Okay. See, here at 0 and after applying padding, my formula will change. My equation formula will change. What is this? Now, my formula is N, my input size of image, plus 2P, P means padding, minus F, plus 1. So 5 plus 2, because I have used one padding layer, because of that P equal to 1, minus 3 plus 1. So my answer is 5. So my output image size is 5 cross 5. My input image size also 5 cross 5 and my output image size also the 5 cross 5. Here we will not lose any kind of information. This is the advantage of that padding. Okay. Let's do some code. Coding is very important because only computer understand coding language, not theory. So let's see about the coding. Here I have uploaded the MNIST dataset. In MNIST dataset, the handwritten digit is there. Okay, I have uploaded and I have used that Keras. There is TensorFlow and Keras, some framework of Python. Here in Keras, there are two types of padding. One is valid and one is same. Here, first of all, I have used valid padding. So after using the valid padding, my input size, first my input size is 26, then my input size reduced, that is 24. Here, applying padding equal to same, see, first of all, my input size is 28, and after using same padding, my padding name is same, okay, don't confuse. Same padding, my input size in next layer also 28. So here we will not lose any kind of image information. Okay. There is another concept. What is this? The another concept? The another concept is stride. So in stride, what happens? See the picture. Stride means jumping from one layer to another layer. Stride equal to 1 means 1 times jumps to one place to another place. And stride 2 means 2 times jump from one layer to another layer. Using stride, my output image size also reduced. Here we also lose some kind of information, but some use cases we will use stride. Why? Because in some use cases, only high level feature is required. There no low level feature is not required in that particular case. Only high level feature is required. So in that type of use case, we will use the stride concept. See, deep learning based on each and every use cases. There is no permanent solution. It is based on each and every use cases. And my computation power also will less using stride because my input size is suppose consider 5 cross 5 and my output size is after using stride 3 cross 3. So computational power also decrease using the stride. But we will not use stride in each and every cases. We'll use stride only use cases wise. Okay. Let's see one things. After using stride, my formula is n plus 2p minus a plus 1 by s. S because of the stride value. If jumping 1 time, then stride equal to 1. Jumping 2 times, then stride equal to 2. I'm showing again how jumping from one layer to another layer. Please see carefully. Here, jumping one layer to another layer. Here, stride equal to 1. Okay. 1 times jumps only. Next one important conception will come. So now what I am discussing? Now I was discussing only the convolutional layer, the convolutional operation. First, I have taken one image and I want to element wise multiply the image and filter. Then my feature map introduced. Then I have used padding because I want no information will lose. So I have used padding and striped. Then I will use pooling layer. What is pooling layer? How, why we will use this? See, first of all, I am going to discuss about that max pooling. Then I will slowly explain what is pooling, what it will do. In max pooling, see, this is one matrix. Matrix means image. Here, first, I am considering that 4x4 matrix. What is the max element here? 7. So, 7, my output. Here, what is the maximum element? 22. So, I will put 22. Here, 11. So, I will put 11. Here, 14 is maximum. That's why I will put 14. Why I have used this pooling? Because, see, here, there is one cat image. Okay. And there another cat image. In this first cat image, the image is not prominent. And this cat image, my drawing is so bad, please consider. And this cat image, the image is prominent. So I will choose only the prominent image, only the important feature of that particular image. So I will use max pooling. Okay, let's see. My slide. Feature map reduce. Why you will use pooling? Suppose my feature map size is 18 cross 18. Using pooling layer, what happened? Only important feature extract. So 18 in 18 cross 18 image, we'll consider only 9 cross 9 because 9 cross 9 image extract only important feature. That's why we'll choose pooling because feature map reduced because of pooling. Next, translation invariance. This is the very important concept. What is this? Suppose my one cat is here, my one cat, and my another cat is sitting here. So in that location, nothing will be happen. Here we will not consider the location. Here we will consider the image, not location. Image means feature of that image. We will consider my eye, not my eye, cat's eye is proper in this image or not? Not location. We will only consider that feature of the particular image. So this is translation invariance. Next is enhance feature. What is enhance feature? Suppose in this image, there is blur. The image is very blur. After using max pooling, my image is so clear. Okay. So enhance feature. Also, we will use pooling. And here in pooling layer, no required to training each and everything again and again. There is no required of these things. But there is also one disadvantage. What the disadvantage? The disadvantage is in image segmentation case, the location is very important. Because of that location, we segment that particular image. So in image segmentation case, we will not use the pooling layer. We will only use pooling layer efficiently in our convolutional case. Okay. Next. Now I am going to discuss about the whole CNN things. See, this is the zebra. We all have seen zebra in museum, not museum, zoo. Okay. So first I have done convolution, and plus I have at ReLU. What is ReLU? ReLU is the activation function. So what is activation function? Suppose here one hot object is there. Consider one hot Rasgulla is there. Okay. So I put this hot object in my hand. So my neuron is active, and because of that hot object, I will throw the hot object from my hand. Same things happened here also. Because of that activation function, the neuron got activated. Okay. And what ReLU do? ReLU will do, if I will pass positive value, suppose +5. I will pass +5, then my output is 5 only. If I will pass negative value, then ReLU will convert negative value to 0. This ReLU will do. So here I have added ReLU. Convolution plus ReLU. Then I have added pooling, because I only want the important feature from that particular image. Because of that, I have added the pooling layer. Then all things I have added that convolution plus ReLU, plus I have done my stride, my padding, all those kind of things, and I have added that pooling. Then I will pass that flatten, whole things in flatten layer. What flatten will do? See, this is my value 7, 22, 11, 14. So flatten, what it do? It elongated that value 7, 22, 11, 14. It will convert to 2D to 1D. And then it will pass whole into the neural network. It will pass whole into the neural network. This is my fully connected layer. See, there is the image of zebra. And in my output, I have used the softmax function. What softmax will do? Softmax will give the probability value, and the sum of probability is equal to 1. It should be equal to 1. Here, my 0.2% probability of horse. Here, 0.7% probability of zebra. Here, 0.1% probability of dog. So which probability is more? Zebra probability is more. So I will say the image is zebra. Am I right? So the whole things happened using CNN. Now, now in mind, the question will come. Why we will use CNN? Because we have already the neural network, the NN. Instead of NN, why we will use CNN? Because, see, suppose my image size, I am considering one image, and my image size is 40 cross 40. And in NN, input layer is there, in middle hidden layer is there, and in last output layer is there. Okay. So suppose consider my hidden layer weight is 100. So what will be my total, what will be my output? My output will be 40 cross 40 into 100. 40 cross 40 into 100. Fine. Because weight transpose X plus B. So ultimately, my output will be very high, and the more computational power is required in deep learning task compared to machine learning. Here, computational power is required more, but unnecessarily the computational power will increase because of using CNN. And another disadvantage is there. Suppose this is the cat image. And in cat image, the feature is very important. The position of that particular feature means eye position is important here. That ear position is very important. In each and every places, the feature is play a very important role. If I will forcefully converted whole image, whole 2D array, suppose this is the 2D array, to 1D array forcefully converted, then some important information will lose. We will lose some important information. So to avoid this type of things, we will, not we, the greatest scientist is there, Ian LeCun. He introduced the concept of CNN. So this is the, in very short, the CNN. I think it is clear. And nowadays, CNN used in so many things. There is so many use cases. Classification. There is traffic sign or not. Using CNN, we will say this. And the advanced kind of things, object detection, helmet detection, or some other object detection, vehicle number plate detection, we will also do using the CNN. So thank you. This is the overall CNN.